clear the start cube and append the mannequin figure from chapter 2. You need to position the man on the origin and make it face along the y-axis, so you may need to do a bit of tweaking. The other thing is you need to have the original mesh precisely on the x=0 plane, and you need to have the mirror modifier before the skin modifier, before the subdivision modifier. So I'm just tweaking it. You also need to, once you've positioned it, apply in object mode, apply all of the transforms. Again, you can make sure that everything is on x equals the spine and head. Once the proportions of the mannequin look okay, we're going to try using the Create Armature option in the skin modifier, which seems like a useful feature, but we'll see there are various problems with using it. You need to apply the mirror modifier before you generate the armature, otherwise it will create half the armature. Try clicking on the button. You'll see that the root of the armature is attached to the first vertex that you started extruding from, so you might need to select the correct one, choose the Set to Root button first. The other thing we'll find later is that although it creates the weights for posing an arm, it doesn't actually parent the skin mesh to the arm. We're going to only sculpt the head figure for this exercise, so it will be a good idea to add a few more vertices to that to allow some rough shaping to be done before we start this sculpting. So I've just selected all these and subdivided them one. With X symmetry set on at the top of the screen, change the shape slightly, pull the chin out, forehead, and make it slightly more head-like. And we're not going to do very much of this because that's the whole point of sculpting, is to do this anyway. When it looks okay, at the top change to sculpt mode, and the first thing we're going to do is adjust the strength of the smoothing. So the strength, you can use the slider at the top or use Shift F. Use F to change the size of the brush. To sculpt in Blender, you either need to have a relatively fine mesh, or you can toggle the dyntopo on, which will automatically subdivide the mesh as you sculpt. And this causes various other problems which we'll see later, but for the purposes of this exercise we will create the detailed mesh using the dyntopo option, selectable right at the top of the screen. So once you've got the strength of the smoothing, reduce the strength of the smoothing, you can practice drawing with clay strips and then pressing Shift whilst you sculpt, which will automatically use the smoothing function. And you need to get the amount of smoothing balanced so that you don't end up undoing everything that you've just done. When everything's set up nicely, click Ctrl-Z to undo all those experiments. And then we're going to start off making this rough and ready face. So using the Control whilst you draw creates the opposite sense for the brush. So you can use a brush that would create a ridge to create a gouge, and similarly with the clay strips you can kind of indent the clay instead of laying strips on top. Start with a horizontal groove across where the eyes are going to be, about halfway up the head, and then indent a couple of sockets kind of coming down below those, so you've got a brow, and then build up with clay strips, build up a nose and kind of gouge down in the opposite sense with the Control to gouge down, and then Shift to smooth, gradually forming the shape of the cheeks and brow, cheekbones and the sides of the nose, and then push the chin out. Use the grab brush, the various grab brushes, the yellow ones, to pull the existing geometry without subdividing, and just change the overall shape. As you move in with dyntopo, well, generally, as you move in, the brush stays the same size, but those size relative to the clay, so to speak, becomes smaller. So you can do finer detail as you zoom in with the mouse wheel. Form the sides of the nose around the nostrils and the nostrils themselves and the web between the nostrils. We're not trying to create a realistic copy of an actual person here, but human faces are hardwired into our psyche, so it's very easy to see faults, and it's a good thing to practice making because it does require good control. When you've got the eye sockets about the right size and the nose, add another object, a sphere, mesh sphere, and position it in one of the eye sockets so it sticks out a bit like an eye. You haven't actually formed the eyelids yet, so it will be more of the eyeball will be visible. And then add a mirror modifier. You probably find that doesn't work until you apply all of the transforms, because the mirror modifier will work around the center point of the object. Once you've got the mirrored eyeball, so you've got an eye in each socket, start to pull the eyelids up using the clay strips and indent so that they actually form a layer apparently over the top. Obviously they'll go inside the ball. You'll notice that getting a sharp edge along the top of the eyelid is essentially impossible using the dyntopo, because it generates a series of triangles as it goes along, and that's something we'll cover in a later chapter when we see how to do retopoing. To create the ears, we're going to use masking. So first of all, make a bulge, and with the dyntopo on, it will subdivide the mesh as you do it. And then once you've got a bit of the ear location, switch to the mask tool and paint around the skull that you don't want to accidentally get distorted. And then use the grab tool to pull the edge of the ear around. Clay strips and other brushes to gradually build up the shape. Again, you probably can't remember what ears look like, and you don't need to worry too much about it. And use the grab tool to generally move things into the right position. Now form a mouth, so create a bulge where the lips are going to, and then build up the top and bottom lip and create the slots between the two. Again, with the dyntopo operating, you'll find that it's difficult to get a clean straight line. That's something that the retopo fix. Again, we don't need it to be a work of art or even realistic. You're just getting the different tools that you can use, getting a facility with them. Again, you can adjust the proportions easily with the grab tool. So here we see that if we try to, if we actually go into edit mode, we can select edges and do some repair. It's never going to be like retopology can. Now when we switch back, we select the armature and try posing the sculpture, we see that various things don't work. A lot of the topology that's been regenerated doesn't have any weight, so the face becomes shredded as we move it, and the eyes haven't got an arm allocated to them. The easiest way to remedy these problems is, first of all, select the eye object and apply the mirror modifier, and then with the eyes modifier selected, select the person mesh and use the join, right-click join, so it's all one mesh. It's possible to see a visualization of the incorrect vertex weights by selecting the mesh and then choosing weight paint mode, and then in the object properties you'll see all of the previous vertex groups, and you can click on those and it will show the weight going from blue to red on the mesh, and you'll see if you select bones, which should have a symmetry like the arms and legs, that will be highlight on both sides. So the best thing to do is to get rid of all the existing bone weights, regenerate them using automatic bone weights. There's a little drop down menu at the side of the vertex groups section in the object properties tab, which has a delete vertex groups option. So delete all the vertex groups, and then you can use one of the menu options in weight paint to do the automatic bone weights, but it's actually much better to use the parent. So select the mesh and then select the armature and right click and parent using automatic bone weights, and that does the parenting as well as the bone weight calculation. Sometimes with convoluted geometry like we've produced with dyntopo sculpting, the automatic bone weight has difficulty calculating correct weights, as in the case here. And when this happens, it's possible to remove the problem vertices by first of all trying merge by distance to get rid of ones that are very close, and if that doesn't work then try decimating the mesh to reduce the number of vertices. Obviously by decimating you're losing some of the resolution, but it will hopefully get rid of the overlapping and very fine faces and vertices.